All right. Hello. So my name is Andy, and this is my first talk, so please be gentle. Today I want to talk about how to make apps with MobX and React. And this is a little bit about myself. So currently I work remotely at a company named Origin in Canada. I'm working as a software developer for about 18 years. For the last 6 years, I would say, I switched to frontend. I used to do backend in the past, because frontend is more fun, as I found it, and people appreciate frontend more. I mean, users and bosses. I have some experience working with MobX and React, some pretty substantial experience, and I want to share it with you today. Okay, so we're gonna split our talk in roughly 2 parts. First, we're gonna talk about MobX and complementary library that's called MobX React and how it works. And in the second part, we're gonna talk about how to use that in real life. Patrick kind of stole one of my slides, but this one he didn't. Who worked with MobX before? All right.
Sounds like MobX. And CMS and PHP.
Yeah, probably. All right, we're gonna skip this question because it was already answered. Okay, so what is MobX? I've seen a lot of comparison with Redux on the web, but I don't think it's very correct, because MobX and Redux are essentially quite different tools. MobX is just a power tool for state management. So for example, if we compare it to building a house, Redux gives you very detailed blueprints and very basic tools. You have to do a lot of things manually on your own. Whereas MobX gives you power tools, like really sophisticated tools, but no blueprints whatsoever. So you have to figure out on your own how to organize your data, how your data flow works, and so on and so forth. So they're very different. So MobX is not an application architecture pattern or a library. It's not like Angular, for example. All right, let's start my favorite part. So we're gonna go over MobX syntax and some of the API, not all of it, of course, but just enough to be able to write apps in it and to understand its core concepts. So MobX is built around a concept of observables, which is totally not new. I think all of you know the concept of observables. And MobX team just implemented it really good. They put a lot of thought in it, made many iterations, and the result is pretty awesome. And well, in my opinion, MobX is not popular enough. It deserves much more, and we're going to try to fix that. So this here is a syntax that you might not end up using a lot, but you kind of have to understand it. You have to know how it works on a lower level. So it's gonna get better. So bear with me. This is how we create an observable value, right? So something that we can later observe. This method box is used for creating observables from primitive values, right? The strings, numbers, booleans, and so on. So we created an observable value, and then we have 2 functions, a set and get, to work with it, right? And since it's an observable value, we can observe it like you can see here. We can pass a handler, basically subscribe to the change, and get the change. So yeah, it's pretty simple and it works. But I would say that it's not that convenient, right? Imagine you have a lot of code, and you write it in this style, it might get ugly. It's not generally convenient to access your properties of your class in this way, right? So let's move a bit further. So this is a bit more advanced and convenient. So here we use the observable function of a MobX, which is receiving an object, a plain JavaScript object. So what this is going to do is going to take your object and convert each property of it to an observable value. But you see how I use it in here? I don't do get, because it's an object and it converts every property to a getter. So when you dereference it, when you dereference this property, in reality you call a function. You call a function that is a getter. And this way MobX has a way to basically make it observable on the background, right? So we've seen how to make regular primitive values observable. This is how to make objects observable. And you can also have observable arrays by passing an array to an observable function. So what does it mean if I have an observable array? What can I observe? Pretty much anything. You can observe the size of the array, whenever something is pushed, whenever something is removed, replaced, everything is subscribable. So again, this is not the best syntax. It's gonna get better. So observable array has the same interface as ES6 arrays, except it has some more methods, some more functions to help you with your code, like remove, observe. So observe just allows you to subscribe, intercept, which allows you to, before the change happens, you can subscribe to a change and you can modify it or cancel it. All right. Also, MobX supports maps, observable maps, so you can create maps from the ES6 map or just via its internal function. And using the map, you can subscribe to the event of new item appearing in the map, or it being replaced, or it being deleted. So this is how it works. Now, just to mention that, of course, not always you want everything you pass to the observable function to convert to observable properties, because sometimes it might be a performance issue and you don't even need it. So there are some modifiers that you can use to cancel this behavior of the MobX. So you can create shell objects or shell arrays. So we talked about how to create observable values. It doesn't make much sense yet, but now we know. So now that we have the observable values, let's look at one more way of creating them, which is, in my opinion, the best one, the one that gives you the cleanest syntax, and it involves using decorators. Who knows what decorators are? Yeah, almost everyone. Anyway, they're pretty simple. It's just wrappers around classes or around class properties. So what this really means is that when your class will be created, it's going to be like an instance of your class, something like that, roughly. Okay, so this is a new syntax, and it's in stage 2, so it's draft, but I'm pretty sure that it's going to be, I mean, for sure it's going to be, because it's already in draft, it's not a proposal, so it's going to be released sometime soon, and it's already heavily used by many companies and many libraries, including Angular, by the way, and I think it's safe to use it, but you always have a choice, of course. So for anything you can do with decorators, you can do without them. But I would encourage you to use them, even TypeScript supports them. Anyway, so this is a way to declare observable value on a class, right? And what does this mean is that, again, it creates getters and setters on background. So you just use it like this. You assign it directly, and you use it directly, the reference is directly, which is pretty convenient. Except this value is observable, not a regular value. You can also have derived values called computed. So why would you use computed value? First of all, it's caching the result, so it will only calculate it once, and then it will recalculate only if a observable has changed, observable that's been used inside, and B, if somebody is actually observing it, which we're going to talk about later. So it's very optimized. And in case you want to be able to set your computers, you can also do it like this. Just create a setter with the same name and do whatever you want inside. Okay, so these are pretty much all of the ways to create observable values in MobX. Now, how to react to them? Because they're not very useful if we can't subscribe or react to them. So this is our class from previous file. It has observable values and computed properties. And this is the simplest way to react to it. So what does this code do? We call a function called autorun, which is a function from MobX, and we pass a function to it, or run. So what happens here is MobX will run this function. So when you execute this code for the first time, it will output the current value of the euros property. But because it runs in the observable context inside of the autorun function, it will subscribe to the euros observable, because this value is observable, right? Well, it's computed, but that's the same thing. So every time this value changes, it's going to run the function that you have passed every time. So as a result, what we created here is a function that logs the value of euros every time it changes. So that's pretty easy. And of course it returns a disposer, which you can call whenever you want to stop this behavior, to stop the updates. You can also throttle the runs, like you don't want to run it every time, you just want to delay the runs or throttle them or debounce them by 1 second or whatever value you want. You can also do that. Now, this is a very convenient way to use observables, and you can put as much as you want in here, like whatever observable you dereference inside, it's going to get subscribed to. But as you may guess, this can be a performance problem in some situations, or just create the executions that you don't really want to do, calculations that you don't really want to do. So yeah, use it wisely. Another way to subscribe to observable is a function called when. So when is a one-time thing. It's not a continuous subscription. So you're waiting for something to happen, or some condition to become true, and then you want to do execute a side effect. So here, what happens is basically it's gonna calculate the return value, and until it's false, it's going to subscribe to all the observables, and it's going to rerun it every time the observables change, until this function returns true or truthfully value. And once that happens, it's going to execute side effect, and it's going to dispose itself. So it's just going to wait until this is true for one time, which is pretty convenient. Of course, it also returns a disposer, and you can basically stop it from waiting for the condition to happen up until the moment that you don't want it anymore. So this is pretty cool. And the last way to subscribe to observables is a reaction. Now, reaction is more more accurate, the way that you have more fine-grained control over the subscriptions. So it kind of resembles Autorun, but you have to specify which observables you want to subscribe to exactly in here, and you have to produce some data to use in your side effect. Something like this. So what's going to happen here is we pass this first function. It's going to execute it, subscribe to all the observables, get the data that this function returned, and then it's going to watch observables. So it's going to execute this function every time the observables change, get the return data, compare it to previous data, and if data has changed, this means that it's time to run the side effect and pass the data to it. So it's literally a reaction to change in your data. So in a simple way, you can use it like this, without any conditions or complicated expressions. So just like this, except this is a number now. So whenever this value changes, just call this function, and this reaction is very similar to what happens in this Autorun. It's exactly the same. Whenever the value changes, call the side effect function. All right, so these are the ways to react. You already got some tools, right, to create some logic based on observables. It's not only for front end, by the way. You can use it in Node.js too, and you can create backend logic using MobX too, and it proved to be very short and easy to understand. Okay, so what do we have next? Actions. Now, remember how we had this Autorun, and it can have a lot of observables in it, right? Which means that it's going to subscribe to all of them. Let's say there are 10 different observables in there, and the Autorun subscribes to all of them. Now, if you're going to change them one by one, this Autorun side effect is going to run as many times as you change your observable values, because it's all synchronous. By the way, yeah, it's all synchronous. So you can improve that by introducing the delay, but that's not always what you can afford to do, not the best way. So one thing to mitigate the situation is MobX actions. MobX actions are like, you can think of them as of database transactions. So you have a function that can do changes to many observables, but the reactions will not be triggered immediately. They will be triggered after this function exits. So it's like a transaction. Also, whatever observables you dereference inside of action, they're not going to be tracked. So, for example, and this is maybe not the best way to do it, but just so you get the understanding. Where was our Autorun? So let's say here, I want to execute a piece of code that uses observables, but I don't really want to subscribe to them. So how can I do it? There is a run in action, which is essentially creating an action and executing it immediately, synchronously. So in here, I can access any observables, and they will not be tracked because they're in action. This is like one of the ways to use actions. Also, they're good to discipline yourself because it's a good idea not to change your observable just anywhere, like anywhere you want, because then it's going to be really hard to keep track of what's happening with your data flow. So it's a good idea to isolate your changes into specific functions, like mutators in Redux or something like that. So MobX can let you to basically create this kind of actions. Anyway, there's of course more API to use, like action bound, which creates bound functions lazily, so you don't have to worry about this. And so this is actions. Now to the React MobX. Now MobX itself is a library for state management, but there is also MobX React library that uses bindings to MobX and makes the life of React developers better. So this here is a classic React use, right? If you use React, then you know that you have a state, then you have your event handler for the text change, and then whenever it changes, you call setState, and it's going to re-render, right? So in MobX and MobX React, this exact same functionality looks like this. So what MobX React gives us is an observer decorator, or it can be used as high order components. You can just wrap your component in the observer function. So what does this do is it basically creates an auto run, so to speak, from your render function. It runs it in a simple way as auto run does, or a reaction. So whenever you dereference an observable inside render, right, like here, so I have an observable name and I dereference it in here, it subscribes to its changes, and when you change this observable, it's gonna force update, re-render your component. And I haven't done performance tests myself, but from what I've seen, this actually is way more performant than most of the Redux code that you can do manually, because it uses very optimized updates, calculates when it should render and when it shouldn't. So yeah, it's this simple. You just declare your component as an observer, and then you use any observables. They don't have to be defined in here. You can use them from any other place, and it will watch them and it will re-render. So this is pretty much all of the API surface of the MobX. But as I told you before, this is just a tool. You still have no idea how to correctly organize your data. Like Redux tells you create one store, create mutators, create reducers and stuff like that. And, you can organize your application or your library. But here you don't really have anything to use. Now MobX kind of suggests people to use stores, like you have a class named store, and you put all your observables in there, you put all of your functions that mutate the data in there, but that proves to be pretty cumbersome because you create huge classes, and then you try to split them into modules. That's really not convenient. although it might work. So another thing that I would like to tell you about a little, and I really don't have much time, but I guess that's fine. That's not that much to explain, is one of the ways to organize your data flow and your API, your entire application structure using MobX and React. I kind of compiled it from my experience with all kinds of libraries, with Angular, with Vue, with Redux. So I came, you know how you write some code or some architecture, some pattern, you come up with something that you're usually not happy with some months later. Well, I found something that I'm happy with for some time. So I would like to suggest you to try to maybe use it too. So what's the idea behind this? So you create the entry point to your application, whether or not it's a web app or maybe it's a library. It's the same. You just create a class that's gonna hold all of your API. So it's like entrance into your API. And you do it manually because TypeScript. Of course, if you don't use TypeScript, you can do it dynamically. So here you define several concepts, which are like flux lightning, that they might be like look like something that you already know use. So first concept is store. Store is just some place where you store observable data and derived observable data, which are computers. You don't put any logic in here. You don't put any mutators in here. Only data. So for example, in here, I have a UI store that has some regular properties, observable properties, and computers, right? And you split your stores by, I don't know, logical domain principle. So, for example, I have a settings store in here that has properties for my settings, and then the way to basically serialize and deserialize them. So next, after you have your data, you can have actions. Actions are supposed to change, so these are not MobX actions, just higher level actions, are supposed to change your data. So this is the only place that that you can use for changing your data in your stores. And of course, this is not enforced by any other code. It's just in your head, in the way you organize your code. But it's quite easy to do. So you just have your actions for changing the data in stores. Then you have your side effects, which is also functions for changing not pure, but simple functions to change data, but they don't change data in stores. They change data in any other external system, like you want to change something in local storage or get from local storage, or you want to reload your window, or you want to, I don't know, call some other browser API or write a file. You can do it from side effect. And then you can have reactions. So here you can put everything that reacts to some event synchronously, right? So what is that? Obviously MobX observable reactions, like whatever happens in MobX, you can subscribe to it and you can perform some actions to modify your data or call network or whatever. You can subscribe to timer events, so you can set timeout or set interval, and this is a reaction basically to timer event. And I don't know, whatever other events there are, you can do it in here. For example, I have the settings reaction. This is some helper that abstracts away some logic. Doesn't matter now. Anyway, so what does it do? It's a MobX, it's observable value, right? Settings are observable. When I serialize, I dereference all the observables I want, and I watch them. So whenever my settings change, what I want to do, I want to save them to local storage using my side effect. This is how I do it. So these are reactions. And you create a little start method that you call whenever you're ready for your application to start, because it's not a good idea to do it at the moment you create an instance of your application. Further, you can split this on many modules. Like you can create modules that have sub-applications or sub-modules. This is pretty scalable. I use it in several apps for quite some time now, and it's pretty cool. Yeah, so I'm out of time, and this is pretty much everything I was going to talk about in these rough pieces. These sources are on GitHub. You can use them. And one reason I actually wanted to do this talk is because I think I'm into something in here with this pattern, and I would really like to have some collaborators, people who maybe will like this idea and will try to make something of it with me. Maybe a template repository, maybe a library, I don't know. We can talk. So if you're interested, please contact me and we can talk about it. So yeah, I would like to thank the organizers of this event. It's been pretty cool.
Thank you.
Thank you.